Hey friends, welcome back to the channel. In this video we will talk about generics and traits in Rust. Imagine you have the following function. Function getPrice that accepts a price of type i32 and returns a price of also type i32. Now let's try to call the function. We can say print the prices and then we call the function and pass in 10. If you run the code, you should see the price is 10. What if we want to pass in here 10.5? So if we say here 10.5, you see that we are seeing an error here. It says mismatch type because price is expected to be of type i32 and here we're passing it as a float. So how can we solve this problem? So maybe you can create another function here called, for example, get float price. And it's very similar to the get price with the difference that it actually accepts a float of i32 and returns float and says price here. So if you use that function here, the problem is gone. So if you run the code, we should be able to see both print statements. What if we want to pass the price as string? Maybe we can do get price and we can pass in here 25, for example. You can see here that we're also getting a mismatch types error. It says expected i32, but we found a slice string. To fix this, we can maybe create another function called getStringPrice and use it here, and then change the float to string. We also need to add .toString here to convert this to a string. Now if you run this code, you should be able to see our printing statements. You can start to see the problem here. Every time we need to pass in or use a different type, we're having to create a new function for it. It would be awesome if we can have one function that can accept multiple types or different types without having to recreate that function for every type. Luckily, Rust has the concept called generics, which allows you to define a struct, a function, or even a trait, which we will be discussing later, that can work with multiple types rather than being specific to one type. Now, to create our generic function, we can do something like get generic price, and then we use the angle brackets here to say this is a generic function, and then we pass in capital T here. Capital T here means it's a generic. The type is generic, so it can be anything you want as long as it's capitalized. So we can say here, for example, my type instead. Basically what this does, it's saying to this function, I want to pass in a price of whatever type I want, and I want to return the same type. Now, if we replace these functions with our generic one, and if we try to run the code, you see that it shows the three different printing statements. Now we can clean up our code a bit, and we can remove these functions, and maybe we can rename this function to getPrice instead. And now this looks a lot better. Now we can basically have one function that gives us the price, whether it's a float number or a string or even an integer. We can also define structs to use generic type parameters. And if you look at this example, you see that we're creating a point here that accepts or that has x and y, and we're printing it out. So obviously if we print this out, you should be able to see x is 1 and y is 2. Now, if we want to make this generic, and let's say we want to have here a float point, we want to pass in here 1.5 as an example, and then 2.5. You see that this will fail. It's basically saying that it's seeing mismatched types. Expected i32 but found a floating point number. So to solve this problem, we can leverage generics again. So to create a generic struct here, we can also use the angled brackets, and we can use T here, as we've learned, and we can replace the i32 here with T. Now this is saying that we have a struct called point that accepts some generic type, and it's assigning it to both x and y. So now you see here that this point is of type i32, and this float point is of type floating point. Now a struct here has the same generic type for both x and y. If we want to define a struct that has maybe x is one type and y is a different type, we can pass in another one here saying, for example, t, and we have u as well. And then, for example, y here would be u. Now we can create a new struct here. We can call it float point and int, and we can pass in 1.5 and then 2. Now if you see the type here, the type hint, it says that the first element here, which is x, is of type floating number, and the second one is of type integer. So this way we are able to create a generic struct that accepts two different generic types. If you remember, we can implement methods on structs. And since we're using a generic struct here, we can implement a method and also use a generic type in its definition. Let's implement a method here that prints out or returns the value of x. To do so, we can use the following syntax. We want to implement a struct that is generic and accepts a generic type, and the function will basically return whatever the value of x is. Now let's use our method here in our printing statement down there, and just by basically adding a parenthesis here to call it. And if we run the code, you see that it shows x equal 1 and y is 2. And to prove that this is generic, let's say 1.5 here and maybe like 2.5. And now if we run the code again, we should be able to see x is 1.5 and y is 2.5. Similar to structs, we can define a generic enum. If you look at this example here, you see that we have an enum called example that has two different options, example A and example B, and both accepts I32. To convert this enum to a generic one, you can add a angled brackets here and pass in t, and then we can replace the I32 here with t. Now to use this enum, you can do something like this. For example, you can say let a equal example A and pass in 1, and example A again, and you can pass in 1.5. And you can see that the type being passed here is, first one is I32 and the second one is F64, which means that we are able to change the type. Now let's discuss traits. So traits allows us to define some shared behavior that can be used with other types. It's kind of similar to how interfaces work in other languages. However, there are some key differences. To define a trait, you can use the keyword trait followed by some name, and then you can use the curly brackets. Inside the trait body or inside the curly brackets, you can basically pass any functionality that you want. Let's look at the following example. In this example, we're saying that we have a struct called pet, and pet has a name of type string. Then we create a trait called cat that has a function or a method called run, and basically it just prints out a statement for us. Now if you want to use this trait and you want to add the functionality of this trait to the struct here, what we can do is say implement cat for pet. What this line is saying, I want to implement the cat trait for the pet struct. In other words, it's saying I want to add the functionality of this trait here to our struct here. So if we now create a new struct here by saying p is equal to pet and then give it a name, now if this implementation works, we should be able to say something like p dot, and we can use the method run. Now if we run our code, we should be able to see this line here, cat is running. Now if you want to create another function or a method that will override the one we have in this trait, you can define it inside of the implementation. So you can say we have a function run that accepts self and prints something else. Now if you run this code, you should be able to see running instead of cat is running. Rust provides many built-in traits that we can use. For example, let's use the display trait, which allows us to customize how we print something. So what I want to do here is I want to implement the display trait for pet, and we need to import this one. So we can say import fmt, the core one. And what this code is saying is I want to add the functionality of this display trait to our pet. Specifically, this code here will allow us to use the .toString on the pet. So if we add a function here called print pet, that accepts a pet of type string, and then we can print on a new line pet. Now if we use this print statement here, and we can say print pet and pass in p dot to string, now what happens is we are passing in the toString version of this struct, and when we call println, instead of just printing this name, it's going to basically print whatever we pass in here plus the is running string. Now if we run our code, you see that it says cat name is running. So the cat name here is this name, and then we are adding to it is running. Now to learn a bit more about the display trait here, let's first comment this one and then go down a bit and see that we have an error here. It says pet doesn't implement the display trait, and obviously we shouldn't be able to call toString on a struct. And so when we add this code here, you see that it allows us to call it. If we go to the documentation page of the display trait here and read, it says implementing this trait for a type will automatically implement the toString trait for the type, allowing the usage of the .toString method. And if we click on the .toString, you see it says convert the given value to a string. And this allows us basically to convert any value we want to a string. So if you look at this example, you see that they're assigning 5 to I and the string version of it to the variable 5. Then they're checking if this 5 is equal to I.toString. So why can we call toString on this I? If you look below this example, you see that they're saying they're implementing toString for I8. And you know that I equal 5 here is of type I8. So because you're implementing toString for this type, it means now you're able to call .toString on any I8 value. So now saying I.toString is going to convert this I8 value to the string version. So this assertion is actually going to be true. So now if we get back to our code, we now know that anytime we implement the display trait on our struct, in this case it's the pet struct, we will be able to call the .toString on it. So now when we call toString on our pet struct, what we're doing is we're pulling the name and we want to print it out, but then we want to print it out with the following format that we defined inside the FMT function or method. And because we implemented the display, this allowed us to use this .toString function. That's everything I wanted to cover about generics and traits. There's obviously a lot more we can talk about when it comes to these two topics. However, to keep this lesson beginner friendly and easy to understand, we'll stop here and we will continue learning about other Rust concepts in the next video.